Hi Neet Aspirants, welcome to Vari Medical Academy. Vari Medical Academy சார்பாக அனைத்து விதமான டாபிக் சார்ந்த ஒவ்வொரு வீடியோவும் இனி வரும் நாட்களில் உங்களுக்கு வரும். உங்களுக்கு இதை சார்ந்த சந்தேகங்கள் கேள்விகள் எதுவாக இருந்தாலும் கமெண்ட்ஸில் பாஸ் பண்ணுங்கள். எங்கள் எக்ஸ்பர்ட் ஃபேக்கல்ட்டி மெம்பர்ஸ் போடுற வீடியோஸ் பிடிச்சிருந்ததுன்னா ஷேர் பண்ணிக்கோங்க. அந்த வீடியோ ரெகுலராக உங்களுக்கு வரணும்னா சேனலை சப்ஸ்கிரைப் பண்ணிக்கோங்க. தேங்க்யூ. Wish you all the best.
Yes, good morning students. In chemical bonding we are explained VBT, hybridization, Lewis dot structures, and please follow my videos, and we uploaded already basic concepts of chemistry and chemical bonding. And today class is hydrogen bonding. Already we discussed in first class there are two types of bonding. One is intramolecular hydrogen bonding, intermolecular hydrogen bonding. In intramolecular hydrogen bonding means within the molecule, for example covalent bond, ionic bond and metallic bond. These bonds are the very stronger compared to van der Waals force of attraction or van der Waals bond or hydrogen bond. Ionic bond and covalent bonds and metallic bonds are under the category of intramolecular hydrogen bonding, and intermolecular hydrogen bonding is we can discuss hydrogen bonding and van der Waals forces of attraction. What are the van der Waals forces of attraction? In actually real gases, in a real gas in between the molecules, intermolecular forces. This intermolecular forces means that is responsible for potential energy. Intermolecular forces responsible for potential energy, and due to motion, due to atoms or molecular motion, to give kinetic energy or thermal energy. Thermal energy nothing but thermal energy in the form of kinetic energy. Kinetic energy is directly proportional to absolute temperature, average absolute temperature. We can discuss in van der Waals forces of attraction. And now today class we can discuss hydrogen bonding. Now hydrogen bonding means electron deficient hydrogen atom, electron rich heteroatom. The bond formation is called hydrogen bonding. What is the students? The electron rich heteroatom, electron deficient hydrogen atom, the bond formation is called hydrogen bonding. Here is we can take a simple A, that is H, another one is the B. B is having lone pair of electrons, and now AHB, the electron deficient hydrogen atom, electron rich heteroatom. Electron rich heteroatom, which one? That is the heteroatoms like fluorine, sulfur and oxygen, and sometimes chlorine also. And these are the heteroatom. These heteroatoms contain lone pair of electrons. The electron, this A atom also electronegative atom, and B atom also electronegativity atom. Electronegativity atom is the smaller size lone pair of electrons. What is electronegativity? There is attracting nature. Attracting nature is electronegativity. Accepting nature is electron affinity. Now electron rich, this one is the bond formation between electron rich heteroatom, electron deficient hydrogen atom. This is called hydrogen bond. This is called hydrogen bond. Here also electronegativity atom means here also oxygen or sulfur or fluorine, but A atom electronegativity is more compared to B atom. A atom electronegativity is more compared to B atom, then only the bond is very stronger. If I am taking in the A place, I am taking that is the fluorine, F and H. FH, that is hydrogen bonding with oxygen, OH, oxygen. Here is which one is more electronegative? Fluorine is A atom is more electronegative compared to oxygen. Oxygen and fluorine, which one is more electronegative? Fluorine is the more electronegativity in the periodic table. That's why this bond strength is increases. FH and OH. Always here is A atom electronegativity increases, the bond strength is increases. If you take here I am taking OH. Here I am taking OH, hydrogen bonding with electron rich heteroatom, electron deficient hydrogen atom. Here is NH3 is there. Here is oxygen and nitrogen. Which one is more electronegative? Oxygen is more electronegative compared to nitrogen. This bond is the more stronger bond. If you take here oxygen, here is fluorine, means that is the bond strength is less only. Now A to H, which bond is formed? Covalent bond is formed. A to H, here A to H, covalent bond is present. Covalent bond. Now, and H to B, this is the hydrogen bond. HB, hydrogen bond is present. Now, bond energy, I am writing here, bond energy of AH or HAH. Bond energy of AH is greater than bond energy of HB. Here is why? Because more bond energy, because and A and H there is a covalent bond is present, and H and B there is a hydrogen bond is present. Which one is the more energy? Covalent bond. Actually covalent bond is the 200 to 400 kilojoules per mole. Kilojoules per mole. For example, hydrogen bonding is 20 to 40 kilojoules per mole. This is the energy. Which one is more energy? This one, 200. That's why the covalent bond, AH bond is, A and H bond is covalent bond. H and B bond is hydrogen bond. Now, what is the hydrogen bonding, students? Hydrogen bonding means AHB, the bond formation between electron rich heteroatom. Electron rich heteroatom must be electronegative, smaller size, it is having lone pair of electron. Electron rich heteroatom, electron deficient hydrogen atom, the bond formation is called as hydrogen bond. Here also A and H, always A is the more electronegativity compared to B atom, then only the bond is the stronger. Because I am taking in A place fluorine, here B place oxygen, here fluorine is the more electronegativity compared to oxygen. That's why this is the strength of bond is increases. Now bond energy purpose, bond energy A and H bond is covalent, and H and B bond is, that is hydrogen bond. Now covalent bond is more stronger than hydrogen bond, and this is the hydrogen bonding, the first. Next one, hydrogen bonding is divided into two types. Hydrogen bonding is divided into two types. One is intermolecular hydrogen bonding, another one is intramolecular hydrogen bonding. Write down intermolecular. There are two types of hydrogen bonding. One is intermolecular hydrogen bonding. Write down intermolecular hydrogen bonding. What is intermolecular hydrogen bonding? In between the molecules, the bond formation is called inter. Within a molecule, the bond formation is called intra. For example, we can take HF. I am taking H and hydrogen fluoride. Here is electron rich heteroatom is fluorine, electron deficient species is hydrogen. This is the bond formation HF. Here also F. electron rich heteroatom, electron deficient hydrogen atom. In between two molecules, HF, intermolecular hydrogen bonding. Here also again hydrogen and F. Here also electron rich heteroatom, electron deficient hydrogen atom. This is the HF is the strongest hydrogen bonding is present. We compare to NH3, H2O and HF. Next, intermolecular hydrogen bonding, another example is water. We can take water also, hydrogen bonding is present. Here is lone pair of electrons and another one interacting with, here is hydrogen and lone pair of electrons and hydrogen and hydrogen. Here also this type of hydrogen bonding. Now this one is example of intermolecular hydrogen bonding. Intermolecular, in between one water molecule, another water molecule. Here is electron deficient hydrogen atom, electron rich hetero atom. This is called intermolecular hydrogen bonding. And each water molecule forms around 4 hydrogen bonds. Each water molecule forms 4 hydrogen bonds in between surrounding. For example, this water molecule, this hydrogen, another hydrogen bonds, this one is another hydrogen. The two lone pairs are present now. These are the involved in other 2 hydrogen bonds. Now each water molecule, how many hydrogen bonds forms? 4 hydrogen bonds forms. Next one is NH3, NH3. Here also NH3 and NH3. Here is lone pair of electrons, is electron rich heteroatom, electron deficient hydrogen atom. Here also lone pair is present, electron rich heteroatom, electron deficient hydrogen atom. That is called intermolecular hydrogen bonding. This is also an example of intermolecular hydrogen bonding. Electron rich heteroatom, electron deficient hydrogen atom. That is also intermolecular hydrogen bonding. Next one is carboxylic acid. RCOOH. This is the dimerization. Here also C, here is OH, here CO double bond R. Here is electron rich heteroatom, electron deficient hydrogen atom, electron rich heteroatom, electron deficient. This is also intermolecular hydrogen bonding, dimer of carboxylic acid, RCOH and RCOH. Here is lone pair of electrons are present. These lone pairs means electron rich heteroatom, electron deficient hydrogen atom. Even boric acid H3BO3 also hydrogen bonding is present. That is also intermolecular hydrogen bonding. For example, question, Na plus is there and NH4 plus, which one is more soluble in water? The question, Na plus and NH4 plus, which one is more soluble in water? You know, Na plus in soluble in water, what is the interaction is present? Ion dipole interaction. Ion means this is the plus and the negative end oxygen, this is the negative pole, again hydrogen. Here also minus hydrogen, here also minus hydrogen. Here is ion dipole interaction is present. Here how many hydrogen bonds are formed in NH3? Here is hydrogen, here also one hydrogen, here also one hydrogen, here is one hydrogen. This one is hydrogen bonding. This one also involved, this one also involved, 4 hydrogen bonds. The more hydrogen bonds means more soluble in water. Here is which one is more soluble in water? Because NH4 plus is more hydrogen bonds are present. That's why NH4 plus is more soluble in water compared to Na plus. Na plus and water molecule, what is the interaction is present? This is the ion dipole interaction. Ion dipole interactions are the weak forces of attraction. That's why Now NH4 plus is more hydrogen bonds. More hydrogen bonds means more soluble in water. Now Na plus and NH4, which one is more soluble? NH4 plus is more soluble in water. If you take a question HF, H2O and NH3, which one is the stronger hydrogen bonding is formed? More stronger hydrogen bonding. Here is HF is more stronger hydrogen bonding, and after H2O, after NH3. NH3 is the compared to HF, HF is the stronger hydrogen bonding after H2O, after NH3. This is the example of intermolecular hydrogen bonding. Intermolecular hydrogen bonding. What is intermolecular hydrogen bonding? In between the molecule. In between the molecule, the hydrogen bonding is called intermolecular hydrogen bonding. If you take intramolecular hydrogen bonding within the molecule, that hydrogen bonding is called intramolecular hydrogen bonding. If you take CHCl3 and acetone, CH3COCH3, here also hydrogen bonding is formed now, because here is chlorine is present, chlorine, here is less, already this is the electron withdrawing groups. Here is carbon and chlorine, which one is more electronegative? Chlorine is more electronegative, that's why it is minus charge, minus, here also minus, del minus, here is plus charges, plus, here is less deficient, no, more deficient. Now here is hydrogen is electron deficient hydrogen atom, the bond between electron rich hetero atom. This is also one of the intermolecular hydrogen bonding. In between CHCl3 and chloroform with acetone, this is hydrogen bonding is intermolecular hydrogen bonding. Now alcohols are more soluble in water, because alcohols are more soluble in water because of more hydrogen bonds are formed. More hydrogen bonds are formed. If you take another one, water I am taking, water, you take a beaker in water, and I am taking ice cubes. These are the ice cubes. Ice cubes are floating on the water. Ice cubes are floating on the water. What is the reason? Because in ice cubes also hydrogen bonding is present. In water also hydrogen bonding is present. Which one is more denser? Water is more denser compared to ice cubes. In ice cubes also, inside cavity is present. Because of cavity, the whole voids are present. It can be floating on the water. All ice cubes are floating on the water. If you take what is the water density? 1 gram centimeter cube. If you take ice, 0.9 gram per centimeter cube. This one, which one is more denser? Water is more denser, because in this one is the ice and this one is the water. Which one is more denser? Water is more denser. That's why ice is floating on the water. That is the reason. What is the reason? Because the cavity is present, voids are present inside the ice cube. That's why easily floating on the water. And these are the intermolecular hydrogen bonding. Next one is intramolecular hydrogen bonding. Intramolecular hydrogen bonding, if you take intramolecular hydrogen bonding, orthonitrophenol. This one is the nitrogen, N double bond O. Here is oxygen. Here is orthonitrophenol. If you take a hydrogen here, this one is electron rich heteroatom, electron deficient hydrogen atom. That bond formation is called intramolecular hydrogen bonding within a molecule. This is within a molecule, in between electron deficient, electron rich, electron deficient. Next one is paranitrophenol. Paranitrophenol. Here is OH group is present. Here is NO2, N double bond O, oxygen. Here is orthonitrophenol. Another one is paranitrophenol. This one is paranitrophenol. Phenol group is the OH is present, means benzene phenol. Where is the present nitro group? Para position. Here is where is the position of nitro group? Ortho position. If you take here also OH here, NO2 here, no problem. Now orthonitrophenol is low boiling point. This one is low boiling point. Orthonitrophenol is low boiling point. Here is a high boiling point. This one is high boiling point. What is the reason? Because it is involved in, paranitrophenol is involved in intermolecular hydrogen bonding. Intermolecular means, if you take this one again, here is nitro group. This one is involved in intermolecular hydrogen bonding. That's why high boiling point and less volatile. This one is less volatile. Because of less volatile means more boiling point. Volatile means easily evaporated. Less volatile. Here is, and orthonitrophenol is more volatile. More volatile. If more volatile means less boiling point. More vapor pressure. More vapor pressure. Vapor pressure. More vapors are, if liquid is converted to gas means more vapors are, means more vapor pressure. Here is less vapor pressure. Less vapor pressure means less vapor pressure. Here is less volatile, high boiling point. This one is orthonitrophenol and paranitrophenol. Orthonitrophenol is example of intramolecular hydrogen bonding. Intramolecular hydrogen bonding, HB. Intramolecular hydrogen bonding example is orthonitrophenol. If you take paranitrophenol is intermolecular hydrogen bonding. Intermolecular hydrogen bonding. HB means hydrogen bonding. Please don't confuse orthonitrophenol. We can write like this one, like this also. If you take, don't confuse. Ortho position nitro group is present, N double bond O, here is oxygen, here is OH, this one is hydrogen bonding, intramolecular, where it is no problem. And this one is example of intramolecular hydrogen bonding within a molecule. Orthonitrophenol and paranitrophenol. Paranitrophenol in distillation column easily evaporated, which one? Orthonitrophenol. Because less boiling point, low boiling point, and more volatile. Which one is more volatile nature means easily evaporated, that is called volatility. And more vapor pressure. More vapor pressure means vapor pressure inversely proportional to boiling point. If more vapor pressure, boiling point decreases. Vapor pressure increases, boiling point decreases. If less vapor pressure means more boiling point. If here is more vapors are increases, less boiling point. Boiling point is some, here is easily, it is not vapors are formed, here is easily vapors are formed. This is the example of intramolecular and intermolecular hydrogen bonding. Understand? And next, we can take another example. If you take another compound OH, salicylaldehyde, OH and COH. Here also intramolecular hydrogen bonding is present. Here also intramolecular hydrogen bonding is present. Intramolecule means within a molecule. Now, summary of hydrogen bonding. What is the hydrogen bond? Hydrogen bond means electron deficient hydrogen atom, electron rich hetero atom. The bond formation is called hydrogen bonding. Now, who are involved in hydrogen bonding? Electronegativity of atom, oxygen, nitrogen, fluorine, carbon and chlorine also involved in hydrogen bonding. Hydrogen bonding is stronger than van der Waals force of attraction. But intermolecular, and hydrogen bonding is divided into two types: intramolecular, intermolecular. Inter means within the molecule, inter means in between the molecule, intra means within a molecule.